All right, so number one on this worksheet, this is what we have. We start with the equation of Mg plus N2 produces Mg3N2. This is not a balanced equation. The first step of stoichiometry is to balance the equation. What do we need to do to balance this equation? Yeah, how do we balance it? What do I have to add to balance it? Lucy? So put a 3 in front of magnesium, and we're balanced now, right?
Yay.
All right. Once we're balanced, we're going into the BCA chart. So our B, the B, remember, if you remember, comes from the question. So number one tells me that I have 8 atoms of magnesium, and I have 2 molecules of nitrogen. How many molecules of the magnesium nitride do we have? Have we done this reaction at all? No. So there should not be any products. So this is 0. Everybody cool with the B part of the BCA?
Yes.
All right. When we get to the C, the change, the first thing we have to determine is, what is our factor? We find that factor by saying, I have 8 magnesiums. Every batch I make uses 3. So how many batches could I make from this? The number comes to 2.67. Does that make sense to everybody? Okay, in nitrogen, I have 2. I need 1 for each batch. How many batches could I make from this? This is 2 exactly. Which number demonstrates the one that I'm going to run out of first, which is the lowest number of these 2? It's this 2. So this 2 becomes our multiplier, our factor for the change line. So I'm going to take this 2 times the coefficient for this column. So 2 times 3 is what? And since it's a reactant, we're using it so that we're taking that away. So that's a negative. 2 times 1 is what?
2.
That's a reactant. We're taking it away, so it's a negative. And then 2 times 1 is what?
2.
But this one's a product. Are we taking it away or are we going to add it?
Add it.
We're going to add this. Perfect. So next, we go to our after line. So we can do this reaction with what we had. What's going to be left? How many magnesiums will be left? Which makes this what?
Excess.
This is excess. How many nitrogens will be left over?
0.
0, which makes this the limiting reactant. How many magnesium nitrides are we going to make?
2.
Which makes this the
A lot.
theoretical yield. Okay, now comes the part where people have a big problem on the test. Up until now, all of the particle pictures we've had have demonstrated clean reactions, meaning all of the reactants are going to react with each other and create products. There were no reactants left over. When you're in stoichiometry and you're doing limiting reagent type equations, there will always be reactants left over. So since there's always reactants left over, they have to be present in the particle pictures. So what we do is, this line right here is the before picture. So if you look at the worksheet, the before picture that they already give you shows that you have 8 magnesiums and 2 molecules of nitrogen. So that's completed. Now we have to make our after picture. Where do you guys think we're going to get the information for the after picture? The after line. So this is the after picture. So how many magnesiums are we going to draw?
2.
So we're going to draw 2 magnesiums. Excellent. How many nitrogen molecules are we going to draw? What'd you say right there?
0.
0. So no nitrogens. How many magnesium nitrides are we going to make? We're going to make 2 of these. So we're going to have 3 magnesiums 2 times. And each one of these is going to have 2 nitrogens on it. That's how you do number 1. Is everybody cool with that? Because this is a molecule. The molecule's formula is Mg3N2. So I need to have 3 magnesiums and 2 nitrogens to make up 1 molecule of that substance. All right. Who would like this copy?
Me.
Okay. The next one is the one that catches people the most. Because they think, well, technically I'm right because I have the correct number of particles. But you have to be aware that it has to represent what the equation is telling us. So our equation for number 2 says I have calcium plus oxygen, which produces calcium oxide. Okay? Is this balanced?
No.
No. How do I balance this?
Then 2 in front, 2 on the
2 here, 1 there, 2 here. Everybody cool with that?
Yeah.
Okay, let's do our before line. What does the question tell me I have in the number of calciums? I have 4 calciums. How many oxygen molecules does it say I have? Okay. And how many calcium oxides will I have at this point? None. 0. Because there's been no reaction that has happened yet. Everybody cool with that so far? Okay, now we need to do our change. For every batch, I will use 2 calciums. I have 4. How many batches could I make with this? I can make 2.
Mr. Cole,
Yes, sir.
how did we end up with 2 calcium?
When we balance, we have to balance the equation.
Oh,
All right. For every batch, I will use 1 molecule of oxygen. I have 4. How many batches could I make with that? Which number is smaller?
2.
So this is the factor we're going to use. That one's gone. What is 2 times 2?
4.
So we're taking it away because these are reactions. We're using them. What is 2 times 1?
2.
So I'm going to use -2. 2 times 2 is?
4.
Now we're on the product side, so I'm making those. They're positive. Everybody cool with this? All right, now we're after. What is 4 minus 4?
0.
0, which makes this the limiting reactant. 4 minus 2 is what?
2.
Which makes this the
Excess.
excess. 0 plus 4 is what?
4.
Which is makes this the?
1.
This is our theoretical yield. Everybody with me on this?
Yeah.
All right. Before, after. All right, so what am I going to draw on the before line?
A B.
I'm going to draw the B. So how many calciums would I draw?
4.
I'm going to draw 4 calcium. I can do it like that because it's calcium. It doesn't matter. I know it's going to be like that. If I touch them, it's not going to be a big deal. If I don't touch them, it's not a big deal. The ones that have to touch are molecules that have a subscript. So that would include all diatomic molecules, and it would include all compounds. Those have to touch in their compound form. You can separate the molecules but the compound itself has to be connected. Okay? How many of the oxygens am I going to make?
4.
4.
See that?
Yeah.
So I'm showing I have 4 molecules of O2. Everybody with me on that? All right. So the before is drawn. What about the after? What am I going to draw in the after box?
2C.
Which line? I'm going to draw the A line in here, right? So how many calciums am I going to draw?
0.
0. Because that's when we ran out of. How many oxygens am I going to draw?
2.
So I'm going to draw 2 of these molecules of O2. How many products am I going to draw?
2. Oh.
So we draw 4 molecules of calcium oxide. Now, what would happen if these 2 molecules of oxygen were separated into 4 individual particles? Would that be correct?
No.
No, why not?
Because
Because of molecule.
Because oxygen is a molecule. They have to be together. Does that make sense to everybody?
So all
Yeah.
molecules.
All molecules need to be connected together. If you have a metal here and you put them all together because it's a solid, I'm okay with that. If you keep them separated, I'm okay with that. I'm okay with those kind of things. But the molecules have to be like that. Does that make sense to everybody? Okay. Let me stop this one here so we'll have it ready for the people online.